Welcome to the second tutorial on principal component analysis. So in this tutorial we will discuss and we will solve problems on principal component analysis. So as we have discussed during our class time, so PCA is also a algorithm basically to reduce the dimension of the data. So here if you see data is plotted into two-dimensional spaces, so our objective is can we find it out a line or a straight line which represents the data. So ultimately we are converting data, two-dimensional data into a one-dimensional data using PCA. So let's get solved this simple problem on PCA. So you imagine this is the small data set. You have x1 and x2 and these are all records. So you can imagine this is the number of mangoes each student has, and this is the number of maybe apple each student has. So we have four student data: student 1, student 2, student 3 and student 4. So four students data is there. First student has 4 number of mangoes and 11 number of apples. Similarly second student has 8 number of mangoes and 4 number of apples. Similarly all four data we have. So now the next step would be we plot the data. We want to visualize the data, how the data looks into the two-dimensional space. So as the here we have the two variables. One is mango, because each student may have mangoes or maybe apples. So this data is two-dimensional data and we can plot the data. So if there is maybe one more fruit, if each student has, for example banana, if I add one more rows for banana, then we have the three variables, and this data will be three-dimensional data. And if we add one more variable, then four-dimensional data onwards we cannot draw it on a paper. So up to two or three-dimensional data we can still draw it on a paper. So for the demonstration purpose I have just considered a two-dimensional data with four number of records. So four students records and two variables are there, mango and apple. So I just plot all the data. So these are the 4 points, that is first student has 4 mangoes and 11 apple. So that's why you can see this is the mango axis and this is the apple axis. So first student has 4 mangoes and 11 apples. So this is the first student's data point. Similarly this is second point, third point and fourth point. All 4 data points I have just plotted. So now you see there is a trend in the data. So once I plot all the 4 points, you understand from the graph itself that there may be a possibility I can draw a line. If I draw a line something like that, so this line will give you least error. I can represent this for data set into this single line. So anyways, we will run PCA algorithm and let's see PCA algorithm what principal component it gives to us. So the step one for this analysis will be we are calculating the mean or the average value of the data set. So how to find it out mean? So we have the mean of mangoes. So how many overall mangoes are there in the class? So first student has 4 mangoes, second student has 8 mangoes, 13 mangoes and 7 mangoes. So if you add all and divide by 4, you will get the average mangoes in the class. Similarly you can find what is the average number of apple present in the class for all students. So again it is summation of all students apple divided by the number of students. So here it is 4. So 8 and 8.5 is the number of average number of apple and average number of mangoes and average number of apple present in the class. So here you can plot the 8 and 8.5. So this point, middle point, if you see x1 bar and x2 bar is nothing but the average mango and apple present in the data set. So now here you understand there are two axes, right? One is apple axis, another is mango axis. So basically there are two variables present in the data set, and how these two variables interact with each other, how one change of one variable affects other variable. If any student has the mango is increased, how the apple will increase. So what is the relationship between these two data sets, that we are finding out in step 2. So in step 2 basically we are finding out covariance. Covariance is nothing but how these two data are related to each other. Two dimension data, one is apple data, another is mango data. How these two data are related to each other, that we are capturing using covariance matrix. So covariance matrix for will be these are the 4 values you need. So covariance x1 means covariance apple with apple. So apple with apple, how much is the relationship between these two variables, that we are capturing here. Similarly this one is covariance x1 and x2. X2 means we are finding out the relationship between apple versus mango. Similarly here also covariance x2 x1 means mango versus apple, and this one is covariance means relationship between mango versus mango. So these 4 parameters we have to compute and we have to get the S matrix. So S matrix is nothing but the covariance matrix. So let's see how to calculate covariance covariance matrix. So here I think you can just correct it. This will be x1. This is not x2. This first one is covariance x1 with x1, means apple or mango with mango, that we are doing it. So here how to solve it? So first data point, if you see, so this data point, how much it is changing from the average data point, so that we are capturing, that is covariance. So this is x-axis, right? x1 and x1, both is x-axis we are comparing, x1 and x1. So now this data point and this data point, how much is the x difference, that we are finding out. So this data point is here. What is the total x value? Total x value is 8, right? This is 8. Similarly, this data point, what is the x value? X value is this one, the x1 direction value, which is 4. So now we are finding out what is this distance from this point to this point, horizontal distance we are finding out, right? So horizontal distance will be total distance from here to here. Total distance is 8 minus this distance, you will get this remaining distance. So let me draw it here, then this concept will be clear to you. So we want to find it out, what is the horizontal distance between this point and this point. So in that case, what we have to do it, we have to find it out, the total distance of from here to here is 8, right? Here to here it is 8, and then here to here it is 4. So then we can find it out, this one is nothing but 8 minus 4. So same thing is written here, 4 minus 8, it is just a data point minus average point we are doing, so that's fine. So 4 minus 8 is the first point, how much it is deviating from the mean point. And then we are comparing x with x, right? This is x with x, we are comparing both x1 same variable, right? So that's why the same variable means this into this, same thing, that's why we have written square. Similarly, let's consider for second point. Second point is this one. So this point and average point is on the same line. So both the points are into the same line. That's why. So these 2 points are same line. That means there is no horizontal difference. So x1 direction, there is no variation. It is the same. That's why it is written 8 minus 8, no variation. 8 minus 8 means 0. Right? Similarly, if you take third point is 13, right? From here to this point, from here to here, this entire distance is 13, whereas from here to here this distance is 8. So then what will be from here to here, this horizontal distance, it will be 13 minus 8. So this is 13 minus 8 square. Similarly for last point also, last point, this distance is 7 and this average point is 8. So 8 minus 7 or 7 minus 8, we will get it as the distance square. Square means why? Because we are comparing x1 with x1, right? Covariance means we are finding out covariance between two same variables. That's why we kept it square. Now if you simplify this expression, you will get 14. So now find it out, covariance with x1 and x2. Covariance with x1 and x2. X2 means covariance, means we are finding out the relationship between apple and mango. X1 is basically mango and x2 is basically apple. So how to do it? So here what we are doing it, we are comparing x1 with x2, means mango with apple. Then what we have to do, so for example first point is this point. So now we have to compare x direction as well as y direction also, because x direction you have mango and y direction you have apple. So but that's here we have to compare both x and y, x1 and x and y. That's why horizontal as well as vertical, both variations we have to capture now. So from this point to average point, what is the horizontal variation? That already we have calculated, 8 minus 4. So this horizontal distance we are finding out. Now for y variation, means this is the y variation from here to here, y distance now. So y distance will be how much? So mean point height is already we calculated is 8.5, right? Average. So this point height from here to here it is 8.5, and from this point this height is already given in the question, it is 11, right? 11. So what will be this height from here to here? Height will be 11 minus 8.5. So that is written. So this is x difference, which is 4 minus 8, and this is 11 minus 8.5. This is the second point. So this is apple, this is mango, and this one is apple. We are comparing, we are multiplying, means we are finding out the relationship between mango and apple for first data point. Similarly for second data point is exactly x, there is no difference, right? It is same line, there is no variation in the x direction, data is exactly same direction. But y direction there is a definition, a difference, variation. So from here to here, what is the y value? So this height is 4 and this height is 8.5. So 8.5 minus 4, you will have here to here distance. So 8.4 minus 5, 8.4 minus 4. So this distance you will get it, this distance. And 8 minus 8 is 0. So this is for the second data point. Similarly for third data point also, what is the x variation? So from here this is the x variation and this is the y variation from third data point. This is the y variation and from here this is the x variation, right? So same thing we have written and we multiply, and this is the fourth one. So once you compute all this, you will get minus 11. Similarly, now the third one is we are comparing apple with mango. This one was mango with apple, and now third one is apple with mango. So mango with apple and apple with mango, covariance is same. That's why here also no need to calculate, same value you will get it, minus 11. So same value we have written. And fourth one is basically we are comparing now apple with apple. Apple with apple means what? Only y variations we are comparing. So apple with apple means here it will be square, right? Because both are same variable, so that's why we keep squares everywhere. All four data points you have the square. So what is first data point? Y distance. Y distance will be how much? So total height of this point is 11, right? Total height of this point is 11, and this point height is 8.5. We calculated 8.5. So what will be the difference from here to here? This difference will be 11 minus 8.5. So this is the height, right? So total height is 11, and from here to here is 8.5. Then difference will be 11 minus 8.5. So 11 minus 8.5 square, it is the first data point. Similarly, this is for the second data point. Second data point is here. So height, this point height is 8.5 and this point height is 4. So 8.5, 4, so 4 minus 8.5 or 8.5 minus 4 square. Similarly, third data point, fourth data point, if you combine it, you will get the 23. So this is our S matrix. S matrix means the covariance matrix. Now in the second step we calculated. So now we will go into third step. So third step we are finding out the eigenvalues and of the covariance matrix. Covariance matrix already we have calculated. This is the covariance matrix. Now we are finding out eigenvalues of covariance matrix. So let me again write eigenvalues. What you got it? 14 minus 11 minus 11 23. So what we got it here is 14. So covariance matrix S is basically 14, then minus 11, minus 11 and 23. So this is the covariance matrix we calculated in the last slide. So now we are finding out the eigenvalues. Is exactly same process we will follow which we have done it during the SVD. SVD also we have calculated eigenvalues and eigenmatrix, vectors, right? So both step 3 and step 4 is exactly identical what we have done it during the SVD. So here also this is the matrix, you also can practice along with me. So this minus lambda I, so if you recall, this was our matrix minus lambda I, and determinant should be equal to 0. So that is how equation we write it. So now this minus lambda I, so this minus lambda I, how it will be done? Let me do it for you. So S minus lambda I, so lambda will be lambda, I is identity matrix, which is 1 0 0 1. This is our identity matrix. So it is simply matrix subtraction. So what you will get? 14 minus lambda, 1 into lambda is lambda, then minus 11. From here also you will get minus 11, and here you will get 23 minus lambda. So that's what the same thing is written here also. If you see, this is the same thing. So what I got it here also written. So now from this matrix we are finding out the determinant. Determinant will be diagonal members multiplication. So 14 minus lambda, 14 minus lambda into 23 minus lambda minus this off diagonal member. Sorry, this diagonal member, which is minus 11 into minus 11. So these two members. So now if you simplify this equation, that is 14 into 23, then for 23 lambda and plus minus 14 lambda, if you do simplification of this equation, you will get this is the quadratic equation of this problem, right? So now you can solve this equation, quadratic equation, using any formulas which you have studied in the school life, right? So anyway, the normal equation would be lambda. If I write the formula, so it will be minus b. So here b is how much? 37, right? Minus means plus 37 plus minus root over b square minus 4ac, right? B means here 37 square minus 4ac. A means what? 1 into c is 201 by 2a. 2a means 2. So this is the equation, right? If you recall, if you have the equation, ax square plus bx plus c equal to 0. If this is the equation format, then x value will be minus b plus minus root over b square minus 4ac by 2a. So this is the equation for quadratic equation solving, right? You studied in the school level. So here b value will be x coordinate. With x, what is the value? So here with x we have minus 37. So that's why I have written minus 37 minus minus, it is plus 37 plus minus root over b square, right? B square means here b is 37 minus 4 into a. A value is 1 here, right? Here a value is 1. If you see C value is 201, so 201 by 2 into a is 1. So if you solve this equation, and then you will get lambda value is, this is the lambda value. So you will get 2 lambda value. If you use plus, then you will get 1 lambda value. If you use minus, you will get another lambda value. So these two are called eigenvalues, exactly how we have done it during SVD. The same process we have done it here. 2 lambda value is 30.38 and 6.61. So this is the 2 lambda values. Now if you recall in the SVD also, the next step we have done it is the eigenvectors. Eigenvectors, so 2 eigenvalues means you get 2 eigenvectors. Okay, so how to find it out, eigenvectors? So s minus first eigenvalue is lambda 1 and lambda 2. So we will replace the value at the end. So that's why we kept it lambda 1 itself. So lambda 1 minus I into x. Right, x means this matrix, exactly u1 and u2. Similarly to SVD, we have done v1 and v2 here. The same process here also. So we have S matrix is this one, right? So 14 minus 11 minus 11 23. So 14 minus lambda I means what? Identity matrix. Same process, right? Identity matrix. This is the identity matrix, right? So 14 minus lambda I minus 11 and 23 minus lambda I, and this is the u1 and u2 we have to calculate. Now this is simply matrix multiplication. You can do it 14 minus lambda I into u1 minus 11 u2. That's simple multiplication. Similarly 11 minus 1, 11 u1 minus 11 u1 plus 23 minus lambda into ut. So that is the simple multiplication. So this must be equal to 0, right? So this is 0 by 0 matrix. So this must be equal to 0. Then first line equal to 0 and second row is equal to also 0. So now first line, if you rearrange, what will you get? So first line, if you rearrange, what will you get? So this first line, so now if I write from here, I can write 14 minus lambda 1 u1 equal to 11 u2, right? So now from here we can write u1 by 11. So this 11 I came down here equal to u2 by 14 minus lambda 1. The same thing is written here. u1 minus u1 by 11 equal to u2 by 14 minus lambda 1 equal to t. Because why we kept t? Because here both the equations are actually dependent equations, right? That's why we kept is equal to t. So now if you see u1 by 11, so that means you can write u1 by 11 equal to t. So u1 equal to 11t. Similarly, once you know u1 equal to 11t, now you can find it out what is u2. So in this equation only, you substitute the value of u1. So u1 will be 11t by 11 equal to u2 by 14 minus lambda 1. So from here you get u2 equal to 14 minus lambda 1t, right? 11 will get cancelled out. So you have 14 minus lambda 1 into t. So that is written here, u2, 14 minus lambda 1 into t. Simple expression we are doing it. So now the t value, you can take any value. You can, some student can take 1, another student can take 2, 3, any student can take any values. That's fine. So any t value you take it and you substitute. So you will have u1. So capital U1 equal to, so t value is 1 means what? 11, and here also t value is 1 means 14 minus lambda 1. So this is our first eigenvector, right? So now we have not substituted lambda 1 and lambda 2. We just kept it lambda 1, right? Lambda 1 value is this one and lambda 2 value is this one. Already we have calculated. So now what is the length of the matrix? Same thing what we have done it during the SVD also. Same thing we are doing. So this will be square root of 11 square plus 11 square plus 14 minus lambda square. Exactly same thing we have done it during the SVD also. So now here you substitute the value of lambda 1. Lambda 1 is 30.38, right? 30.38 calculated. So lambda 1 30.38, and this expression if you solve, you will get u1. u1 means basically length of the u1 matrix. u1 means what? The unit that is eigenvector is u1. So length of the vector is 19.73. So now our E1 is what? E1 is the first principal component, small e1, equal to this 11 divided by what length you got it. So exactly same thing we have done it during this video also. So E1 equal to 11 by length. So 11 by length is 19.73. Similarly, second one is 14 by lambda 1 by length. So basically we are normalizing the vector with its length. So basically you get the unit vector. So this is our E1, and this E1 is called first principal component, E1. So this U1 is called first principal component. Here U1 already we have computed. This is U1, you replace it, and lambda 1 also 30.38 is the lambda 1, right? So this lambda 1 value you replace it, you will get this is the final expression for E1. So it is 0.55 and minus 0.83. So this is the E1 is first principal component. So what we have done, we have substituted lambda 1 value, right? Lambda 1 value is 30.38. So now to find it out, the second u2, this is u1 we calculated within lambda 1. So now same step can be repeated. U2 also you can calculate by substituting value of lambda 2. Lambda 2 is 6.61, right? So if you substitute 6.61 here, you will get capital U2, length of U2. Then you will have E2 also. So E1 is this one, right? Then you have E2 is the same expression. E2 also will have same expression, but here modulus U1, or now you have U2 because you substitute lambda 2 value 6.61, then you have the U2, right? So same U2 you substitute here, and lambda 2's value also 6.61, then you get this expression. Just substitute the values and you get E2. So E2 is called second principal component. E1 is called first principal component. So if you see what is E1 value, you got it. E1 value you got it 0.55 and minus 0.83, and E2 you got it 0.83 and 0.55. So this is the step 4 where we have calculated the eigenvectors. So now this is the last slide. Now almost problem is solved. So E1 and E2 already we have calculated. So how much was the E1? E1 was, again let's see, E1 is 0.55 and minus 0.83. What is the meaning here? So if I plot E1, so this was our 4 points, right? 1 point, 2 point, 3 point, 4 point, right? So okay, let me take the first picture. Yeah, so this picture, let me erase the earlier. Okay, I cannot erase. I think that option is not there. Anyway, so now if I plot the first eigenvalue, first eigenvalue is this one. So x value is 0.55, y value is minus 0.83, right? So x value is plus 0.55 and y value is minus 0.83. So if I plot these two value, that 0.55 and minus 83, so this is our center point, right? Average point. So from here plus 55 means what? I have to go this side. So this is plus 55 minus a 0.8. So minus 0.8. So plus 55 from here, plus 55 will be here, and minus 0.8 means downward you have to go. Minus means what? Down. So this is the point you get it, vector. So now if you connect these two points, so and you extend the line, so this is the line. That's what this line I am talking about. So this line will give you least error. So if you represent this 4 point into a line, then this will be the line. Then how we got this line? This line we got it based on PCA, principal component analysis. We got this second point and we connected average point with second point and we extended both the directions. So this line is called first principal component line. Okay, so now the last part of this data set is, now we are reducing the dimension. So step 5 is last step. So computation of first principal component, we are doing it. So E1 is what? First principal component, which we have calculated. This one is the E1, 0.55 and minus 0.83. So E1 transpose. So that's why it is now row wise, 0.55 and minus 0.83. So this, now for the first point we are finding out. So for the first point, what will be the first component value? First component value means what? We are projecting first point. We are projecting, this is the first point. We are projecting into this line. So this is the line. We are representing all 4 points into this line. Is not it? So now if you project this first point into this line, what will be the coordinate of this line? That we are finding out. What is the coordinate of this line? So that we are finding out. So for first point, you have the x1 is 4, x2 is 11, right? So here if you see the values, first point x1 it is 4 and x2 is 11. So 4 and 11, and what is the average mean value? Mean value already we calculated x1. Let me again write it here. Mean value we got it 8 and 8.5, right? If you recall in the first slide. So here if I write it, so now this is 8 and this average is 8.5, already we calculated. And for first point, this value is x1 value is how much? 4. So this value is 4, right? And this second value, first point is 11. So this point is 11. So now you have a matrix. This is our E matrix, E transpose, and this is the matrix. All four values you know, 4, 8, and again 11 and 8.5. This two matrices, if you multiply it, you will get the another. If you multiply it, you will get the final value is this one, right? So if you multiply this matrix with this matrix, then you will get the single value, which is minus 4.30. Right, so this is the first matrix, the same matrix. Here I have elaborated the calculation. So this is E transpose, and this is the second part. So second part, I said this value is what? This value is 4. So this value is 4 1. Then 2 1 value is 11, and average value is, average of first one is 8, and average of second data set is 8.5, right? So this all four values if you substitute, and if you do the matrix multiplication, you will get first value is 4.33. Similarly, second point also you can find it out. So in the second point, the instead of 4, this will be 8, right? Second point here, this will be 8, and the y value, this value will be now 4, and remaining all at same. Again, you do the same multiplication, you will get 3.73. Similarly, for third point, you substitute x value is 13, so this value will be 13 for the third point, and bottom value will be 4, so this value will be 5. So again, same calculation, you get it this value. Similarly for the fourth point also. So now if you see, our data was two-dimensional, right? So our data was two-dimensional, x1 and x2. Now we compressed data into one dimension, which is now this is the fourth data. So earlier you have four data in this line, four data in second line. So 8 data you had. Now you can equivalently compress the data into single 4 value. So this is the power of PCA. Basically we are reducing the dimension. So now after, so this point will move to this point, right? So this point will move to this line. So similarly this point will move to this line. So ultimately see all these 4 points are into the single line. So that is how we got the compression PCA value, reduced PCA value. Okay, so this is about PCA calculation tutorial. So please solve in your own hand. It is a very simple process, and try to practice more. Thank you.